All right. Hey, everybody. Welcome back. This video is going to be very short because I want to save, essentially from problem 2 on, I want to save this to be something that we work on in class. But I did want to create a quick video to introduce the new topic that is volumes of revolution, at least to draw more or less what it is. So what is a volume of revolution, or a volume contained by a surface of revolution? I will sometimes use these two terms interchangeably. Well, so what we can do is we can create a surface by constructing two things. First, we have an axis of revolution. So let's just sort of say, oh, there we go. Let's say this is my axis of revolution. And then what we can do is we can take something called a generating curve. All right, so maybe this over here is my generating curve. So what we essentially do then is we have this curve, which is, we can think of it as a one-dimensional kind of object, similar to a line or a piece of string. And then we can revolve the curve around the axis of revolution. And so we do this as follows, right? We're going to essentially spin the axis of revolution, sort of twirl it in place. And in doing so, we are going to wrap each of these, I'll say every point, maybe I should start there, every point on the generating curve will get similarly dragged around in three-dimensional space to create a circle. No, that was a bad drawing. Let's try that one more time. Drawing around in three-dimensional space to create a circle. Similarly, a spot like this, dragged around the axis of revolution to create this circle. This one here, dragged around three-dimensional space to create this circle. And so if we drag every single point around in three-dimensional space, what we'll end up with is a three-dimensional surface like this, or rather a three-dimensional volume that is enclosed by this two-dimensional surface. And so, of course, my drawing leaves a little bit to the imagination, but you can imagine how we take this curve, and by revolving it in space, we can end up with a surface that is containing a certain amount of volume. Down below, we see a slightly clearer picture than whatever I was just trying to draw. Notice down here, we have something imposed on our XY plane. So here, we're going to take the x-axis. This is our axis of revolution. And we can consider a certain curve. We'll work out the details of what this curve is precisely in class. But we could have as a generating curve this line right here. I guess I'll point out this is our x-axis, aka our axis of revolution. This is our y-axis. And this little stretch right here, this is our generating curve. What we can do then is we can twirl the x-axis in place, sort of spinning the rest of space around it. And what we end up with is rotating each of these points to create this sideways cone. End up with something that kind of looks like this. And to be clear, every single point on this original curve is getting revolved around the x-axis, right? Ultimately creating the cone that we see in front of us, aka this cone over here. So what we will see is that if we have a surface of revolution, then we can often calculate the volume as a property of, or using things derived from, this generating curve. And so the generating curve turns out to be a key feature in exploring these surfaces of revolution. Okay, but of course, like I said, I wanted this to be a quick video. We will get into all the fun nitty-gritty in class. So thanks so much for watching, and we'll see you then.